I just made this entire video and didn't have my microphone on, so there's no sound. So let me try again here. We're doing problem 4.2.24, and it has to do with advertisements placed in newspapers 1 and 2. And so if you read the problem, it says, what does it say? It says, let me get it here. Going to the bottom, it says, how many advertisements should Everest place in each newspaper to achieve its advertising goals at a minimal cost? So you're minimizing cost and you're putting ads in 2 papers. So defining variable, x equals number of ads in newspaper 1 and y equals number of ads in newspaper 2. And this comes from the last line. You just have to read it. It says, how many advertisements should Everest place in each newspaper? Well, so the number of advertisements in newspaper 1 is X, and the number of ads in newspaper Y is, or newspaper B is 2 is Y. If there was a third newspaper, we'd have a Z, but we don't. So now we've defined variables. All right, now we're minimizing cost. So the objective function tells us we're minimizing cost. So what does it cost? Right, so cost is going to be each ad in newspaper 1 costs 1,000, so that's 1,000 X. And each ad in newspaper 2 costs 800, so that's 800 Y. So this is your objective function. Okay? So you found that, and now you look for the constraints. And you're really constrained by 3 groups, group A, group B, and group C. So there's going to be 3 constraint functions or inequalities. So we have 70,000 from group A plus 10,000 from group B, so 70,000 group A customers are seen in newspaper 1, and then 10,000, is that 10,000? Oh, there's another 0 here, 10,000, should use some commas here, are from group A going into newspaper 1, and they'd like to have a minimum of 2 million. So that says this is bigger than or equal to 2 mil. And once you figure the first one, I think it's pretty easy. It goes 70, 10, 2 mil. And then it goes 40 for 40,000. 40,000 plus 20,000. And that's greater than or equal to 1.4 mil. And then the third one, group C, is going to be 20,000 plus 40,000 Y is bigger than or equal to 1 mil. Now remember, this is all going into a matrix. So if you divide by 10,000, these constraints become what? They become, so divide, I think, by 10,000. 1, 2, 3, 4. Yeah, 4 zeros. You get, so this becomes 7x plus y is bigger than or equal to 200. 4x plus 4x plus 2y is bigger than or equal to 140. Which next thing you go lower, because you can divide by 2 again. So let's do that. So you get 2x plus y is bigger than or equal to 70. And then the last one is x plus 2y is bigger than or equal to 50. And of course, x and y are positive, right? So we're in quadrant 1. Okay. So when you write down the tableau for the primal problem, so the primal tableau, what do you get? You get x, y constant, 7, 1, 200, 2, 1, 70, 1, 2, 50, and then the objective function 1,800. So that's your tableau for the primal problem. And now we're going to turn it into the dual tableau. I'll put it over here. So it goes 7, oops, hold on. Seven, 1, 200, which is row 1 here. 2, 1, 70, which is row 2. 1, 2, 50, which is row 3. And then 1,800 blank. And this is UVW constant. So now the dual says 7U plus 2V plus W is less than or equal to 1,000. And this says U plus V plus 20W is less than or equal to 800. And the objective function we're trying to maximize is P equals 200U plus 70P plus 50W. Okay. So now you set up your table, or tableau. So U, V, W, X, Y, P, constant. So what is this? 7, 2, 1, 1,000, 1, 1, 2,800. 2,800 minus 200 minus 70 minus 50, 0. And then the piece you have to really understand is that you should have the 3x3 identity matrix on the right here. So there's your initial tableau. 7211001000. 112010800 and minus 200 minus 70 minus 50 001 0. Okay. All right, so now you do all this reducing. I'm not going to do it, it's too much. So you do ... you do all this work, and you wind up with what? You wind up with U, V, W, X, Y, P, constant. And the final is 13 thirds, 1, 0, 2 thirds, minus a third, 0, 400. So this is minus 5 halves. 0, 1. Minus a third, 2/3, 0, 200. And then lastly, you get a 20 here. 0, 0, 30, 10, 1, 38,000. All right, so the solution to the primal is this. X equals 30, y equals 10, and c equals 38,000, because you read off these three guys here. And therefore, Everest should what? Put 30 ads in X, which is newspaper 1, 10 ads in Y, and their cost is $38,000, which is the minimal.